In all science classes, we ask students to define a problem, ask questions, develop and use models, plan experiments, analyze and interpret data, construct explanations, use math, draw conclusions, and communicate the information. To build an understanding of scientific phenomena, students need repeated opportunities to work and develop the fundamental ideas and interconnections for them to build a coherent view of a concept. This is done over a period of years, not during one class, not during one semester. For this to succeed, we must create a framework that emphasizes teaching with explicit connections from one level to the next. Our teaching must change towards a more deliberate, interdisciplinary strategy. Understanding energy is crucial for all STEM students and is considered both a disciplinary core idea and a cross-cutting concept. In chemistry, energy is described for atomic and molecular levels and is typically introduced in terms of potential and kinetic energy of particles. The discussion then moves on to thermodynamics, where enthalpy, internal energy, entropy, and Gibbs free energy are studied. Students should have the tools to solve the problems, which means applying the scientific method, understanding the protocol, executing the experiment, analyzing the data, and arriving at a conclusion through deliberate discussion. Besides the lab manual, an inquiry worksheet for each experiment can be included prior to starting the lab. This worksheet will help them through the lab and facilitate writing the lab report, in addition to reinforcing the concepts encountered in the lab. For example, the worksheet for General Chem 1, measuring enthalpy changes, can include starting the lab by refreshing the concept knowledge with a discussion about energy, including the following questions. What does temperature measure? What is heat? What is the difference? What is thermal energy? Which has more thermal energy, a cup of hot water or a bathtub full of warm water? What variables do we need to account for when transferring heat from one object to another? The second part of the worksheet can include discussions and conclusions from the lab conversation as an introduction into the experiment. We can define the question at hand. How will we test the hypothesis? What is the procedure for the experiment? What type of calculations or equations are needed? What type of data collection is necessary? And how to present the data. Once the experiment is concluded, we add open-ended questions to access the development and fundamental knowledge of the concept. What is the system? What is the surrounding? Can the properties of a solute predict enthalpy changes? Can the properties of a solute change the energy of a system? Using the inquiry worksheet for the beginning of the lab in conjunction with the written lab report rubric is asking the students to go beyond the lab manual. This encourages synthesizing the concept from different points of view while discouraging routine memorization or copying. This approach addresses the student learning outcomes of knowledge content, scientific literacy, and scientific lab skills. Students can also make their own videos of the experiment, and these can be collected and used as digital competency and deposited, or they can be used for other classes. We can help students connect the dots.